Physics Part 421. Pulses of ultrasound are necessary so that the reflected ultrasound pulses can be detected in the time intervals between the transmitted pulses. The time between the transmission of a pulse and its receipt back at the transducer gives information as to the distance of boundary from the transducer. The intensity of the reflected pulse gives information as to the nature of the boundary. Two techniques are in common use for the display of an ultrasound scar. In an A scan, a short pulse of ultrasound is transmitted into the body through the coupling medium, the water-based jelly. At each boundary between media, some of the energy of the pulse is reflected and some is transmitted. The transducer detects the reflected pulses as it now acts as the receiver. The signal is amplified and displayed on a cathode ray oscilloscope, CRO. Reflected pulses echoes received at the transducer from deeper in the body tend to have lower intensity than those reflected from the boundaries near the skin. This is caused not only by absorption of wave energy in the various media, but also on the return of the reflected pulse to the transducer. Some of the energy of the pulse will again be reflected at intervening boundaries. To allow for this, echoes received later at the transducer are amplified more than those received earlier. A vertical line is observed on the screen of the CRO corresponding to the detection of each reflected pulse. The time base of the CRO is calibrated so that, knowing the speed of the ultrasound wave in each medium, the distance between the boundaries can be determined. An example of an A scan is illustrated in the figure. A B scan consists of a series of A scans, all taken from different angles so that on the screen of the CRO a two-dimensional image is formed. Such an image is shown in the figure. The ultrasound probe for a B scan does not consist of a single crystal. Rather, it has an array of small crystals, each one at a slightly different angle to its neighbors. The separate signals received from each of the crystals in the probe are processed. Each reflected pulse is shown on the screen of the CRO as a bright spot in the direction of orientation of the particular crystal that gave rise to the signal. The pattern of the spots builds up to form a two-dimensional image representing the position of the boundaries within the body. The image may be either viewed immediately or photographed or stored in computer memory. The main advantage of the ultrasound scanning compared to X-ray diagnosis is that the health risk to both patients and to the operator is very much less. Also, ultrasound equipment is much more portable and is relatively simple to use. Higher frequencies ultrasound enables greater resolution to be obtained, that is, more detail can be seen. Furthermore, as modern techniques allow for the detection of very low intensity reflected pulses, boundaries between tissues where there is little change in the acoustic impedance can be detected. Next, we've got section summary and section questions. for the upcoming video.